Okay, so if you've been on Firefly since Friday, you will have seen there's a survey sent out about the revision topics that we're going to be doing. So basically my plan is, if you've not done it already, please do go and have a look at that. It'll give you a bit of a say in what revision we're doing. Basically I've split it into different half terms. You can pick more than one from each half term. It's basically just what we'll be doing, practicing for the next few weeks. So I've put the bar chart of the next one in. This is half term 1 topics. So I wasn't super surprised to see that Surds was one of the most requested. So we're going to spend this lesson and next lesson on Surds. Now I think we'll do probably one lesson on solving quadratics. So yeah, today is Surds, as I'm sure you're all very happy with. So we're going to be doing simplifying and multiplying. We'll be doing adding Surds next lesson. Okay, so before we get started on the actual using Surds, we've got to look at some terminology. So real numbers, these are the numbers that are any decimal or whole number. So it's fractions as well, real numbers. You do see imaginary numbers as well, but you won't see them until A level. So rational numbers, so these are ones that you can write as a fraction of integers. So a quarter, you can see that that is 1 over 4. So 1 is a whole number, 4 is a whole number. So that means 1 over 4 is a fraction made of integers, so it is a rational number. 3, though it's not a fraction, you could write it as 3 over 1, which would be a fraction involving integers. Half, again, you can tell it's a fraction, you can see it's integers. Minus 7, same strategy as the 3, it's minus 7 over 1. So all whole numbers and all sort of whole number fractions will be rational numbers. So if you can write it as one of them, it is a rational number. There's then irrational numbers, so this is just any real number which is not rational. So really common ones to look out for with irrational numbers are things like pi. So it's a number, but you can't write it as a fraction. Or think square roots are quite often one as well. So one to be careful of, not necessarily always irrational, but always one to check square roots. So what we're going to do with this one is we're going to try and sort these into their various categories. So we're going to try and work out which section they go in. So looking at them, they are all real numbers. Ignore E for now because we've not looked at that. So they're all real numbers, so they're all at least going to be in this circle. But then there's subsections as well. There's rational numbers and there's integers. So if you want to pause and have a go at this, you can do. If you want to just see me go through it, that is fine as well. So let's start with 3. So it's definitely a real number, so it's definitely at least in this outer one. It is rational because we can write it as a fraction. We can write it as 3 over 1. And it is in fact an integer as well because it's a whole number, so we can write that one there. So we've got 3 ticked off. 0.7. So it's a bit easier to do it as a fraction. So let's write it as 7/10. And we can see that it's definitely a real number, and it is a rational number as well because it is 7 over 10, so it's 2 whole numbers. It's not a whole number though, so 7 over 10, 0.7. So I've done that one now as well. So pi, briefly mentioned this in the previous slide. This is a real number, but it's not a rational number because we can't write it as a fraction. So you could write pi over 1, but because pi isn't a whole number, this isn't an integer fraction, so it wouldn't be a rational number. Okay, 1.3 recurring, so let's have a look at this one. So it is a real number. Is it a rational number? So let's write it as a fraction. So that would actually be 4/3. So 4/3, that is an integer fraction, so that is 4/3 equals 1.3 recurring. But again, it's not an integer because it's not a whole number. Okay, we'll try and speed through these next few. So root 2, it is a real number, but we can't actually write root 2 as a fraction. So this would be in this section, because we can't write it as just an integer fraction. -1, we could write that as -1 over 1, so that would be a rational one. It is actually an integer as well, because it's a whole number. So even though it's negative, it still counts as an integer. We'll ignore the height in meters, we'll just go on to the 3/4 one. So 3/4, it is already written as an integer fraction, so it is in this section, it's not a whole number. And root 9, so I said to be careful of square roots, so we can simplify root 9 actually to 3. So 3 we've actually seen already, this is here. So because root 9 is the same, that goes in this section as well. So something to be careful of. We saw that we've got a square root here, got a square root over here. So just because it's a square root doesn't tell us whether it's rational or irrational, because this one we can actually simplify down to 3. So just be careful, can you simplify it or not? Sometimes if you simplify, you can end up with an integer. Okay, so spoken about rational and irrational numbers. Just got a quick side note of what a surd is. This is the main sort of topic, so this is the definition you'll need to know, but you do need to know all the prerequisite information that we've just been over. So a surd is an irrational number that is based on a square root. So it's basically a root that comes out with an irrational number. So root 2, we saw already, we can't simplify this down, so this is actually a surd. Root 9, we saw that simplified to 3, which is rational. So a surd needs to be irrational and a root. So all of these are roots, so we're basically just checking are they rational or irrational. So this one is not a surd because that one equals 3. Square root of 5, we can't simplify at all, so that would be a surd. Square root of a quarter, so this would be a half. Actually this one is not a surd because we can write that as a rational number because it is an integer fraction. And cube root of 7, we can't simplify that at all, so that would be a surd. So basically surds are irrational numbers that are a root one. So it's a root of a number that produces an irrational number. Okay, so this bit is the key part of the lesson. So we've got all the background knowledge now. This is the key sort of processes that you do with surds in year 9. So if you need 2 key bits of information from this whole lesson, it is this and it is this. You can do a lot of the surds topics with just these 2 things if you're quite crafty with how you use them. So square root of a times b, we can write that as the square root of a times b. So the difference here is this is the square root of a times the square root of b. If we times them together, that is always equal to the square root of a times b. So an example of this, let's say a is 6 and b is 6. So we've got root 6 times root 6. That would equal square root of 36, which is 6, which makes sense because the square root of 6 times the square root of 6 does equal 6, because that's what the square root is. It's if you times it by itself, it equals the number. So I've done a number example here, but actually this is true for all a's and b's. So this is the first rule we need to know. Second rule we need to know is if you've got a square root of a divided by square root of b, that is always equal to square root of a over b. So these 2 rules are really, really crucial. So I'd make a note of these because you'll be using them a lot this lesson. So let's look at a quick example. So it's root 3 times root 2. So we're down here now, root 3 times root 2. Using rule 1, so we've got root 3 times root 2. That would be square root of 3 times 2, which would be the square root of 6. So square root of 3 times square root of 2 is the same as the square root of 6. You can check that on your calculator to check the rule works. Let's go on to this next one. Square root of 1 divided by, square root of 1/9. So using the second rule now, we can simplify this to square root of 1 divided by square root of 9. So we're kind of going from here, going backwards actually for this one, because we're starting off with the square root. So we've got square root of 1 divided by square root of 9. So that is 1 over 3, because square root of 1 is 1, square root of 9 is 3. So you can see with these 2 rules, we've managed to rewrite these surds in a different way. So let's do some practice with this. So this is what we're going to be using for simplifying our rules that we've just looked at. So we're going to look at how we simplify square root of 8. So we're going to use our rule square root of AB equals the square root of A times the square root of B. So this is rule 1 from the previous slide. So square root of a number times the square root of another number equals the square root of those numbers times together. So let's break up 8. Basically what we're looking at, because we've got a square root, we're going to be looking for a square factor of 8. So let's write 8, instead of writing it as 8, let's write it as 4 times 2. And the reason I've done that is because 4 is a square number. And we'll see how that's useful in a second. So because I've got the square root of 4 times 2, I can now write that using this rule here. So if I set A is 4, B is 2, we can write that. So we've got AB, let's write it as square root of 4 times the square root of 2. So we've used our fact that 4 is a square root, so we're going to use the fact that 4 is a square number, because we can now write, where we've got a square root of 4, we can just write 2. So we've got 2 times root 2, or 2 root 2. So we've simplified root 8, we've simplified it down, so now this number in the square root cannot be simplified anymore. That is a prime number now. Okay, so now let's have a look at some other examples of this. So let's do root 27. So again, we're going to be looking for a factor of 27 that is a square number. So let's have a go at this. So root 27, we need to write, we need to work out a factor of 27 that is square. So let's use 9. So we can write this as square root of 9 times 3. So 9 is a square number, so that's why I've picked that one. So using the rule up here, so I've got two numbers times together, I can now split this up. So I can write a square root of 9 times the square root of 3. But we know the square root of 9, that is 3. So we end up with 3 times root 3, or 3 root 3. So basically, by working out a square factor, we can simplify it. We can take that out, and then we can actually do the square root. So if we use the square number factor, we can actually square root it, because we know how to square root a square number. So let's have a look at root 32. So root 32, we can write that as, so square factors of 32, we've got 16, so let's go with that. So we can write that as square root of 16 times 2, so 16 is the square number. So again, writing it as two square roots now, so we've got square root of 16 times square root of 2, and we can square root 16 because we know that is a square number, so we end up with 4 times root 2, or 4 root 2. So notice I'm not writing the times, that is because like for x is 4 times x, 4 root 2 is the same as 4 times root 2. So I'm just writing it in the more compact form like this. Okay, so 2 root 50, this one's a little bit different, so let's go through this one. So 2 root 50, the 2 is actually not a surd, so we don't need to, we can just kind of ignore that for now. So whatever we've got, we know it's 2 times it, but basically we're just going to focus on the root 50. How can we simplify that? So let's leave the 2 for now, so let's write root 50 as root 25 is a square number factor of 50 times 2. So instead of 2 times root 50, we've now got 2 times root 25 times 2, so it's the same thing, we've just taken it, we've broken it into its factors. And then now we can write this as 2 times, this bit hasn't changed, and then we've got square root of 25 times square root of 2. So we've broken up the square root into its 2 parts, so we've used our rule from up here. And then we can now write this in a simpler form. So root 25 is 5, so that would be 2 times, so root 25 becomes 5, root 2 we can't do anything with, so that stays as root 2. So we end up with 2 times 5, which is 10, and then times root 2, so we end up with 10 root 2. And I've run out of space, I'm going to do this next one over here. If you want to pause and have a go at this one, you can do, just to see if you've worked out from the previous ones. So we've got 4 root 12. So let's look at just the root 12. So 4 stays the same, we're not doing anything with that because that's already in its simplest form. Root 12, we've got a square factor of 4. So we can write that as 4 times 3. And again, using our rule, if we've got 2 numbers times together in a square root, we can write it as in 2 separate square roots. So we've got 4 times root 4 times root 3, so that's just broken up now. Root 4 we know is 2, so we've got 4 times 2 times root 3. So then 4 times 2 is 8, and times root 3, so I've got 8 root 3 as our final answer for that one. So I think we're just going to do simplifying today. I'm not sure we'll have time to do multiplication actually. So ignore the fact that I said multiplication, just stick with simplifying for today, just because we're on 15 minutes already. Okay, so here's some practice questions to do before you go on to the main exercise. So pause the video now, have a go at these, then unpause and check your answers as you go along. Okay, so this first one, root 75, I've got a square factor of 25, so you can write this as 5 root 3. Square factor of 4 in this next one, so you can break them up and then write square root of 4 is 2. 48, the biggest square factor we can do is 16, so you can write this as 16 root 3, so root 16 root 3, which becomes 4 root 3. So this one we leave the 3, we've then got 102, so we simplify that and break it down. And last one, 45, we've got 9, we've got 5 times root 9 times root 5, which we can then simplify. Okay, so we're not going to be doing any multiplying or adding of surds today. We'll be doing that in tomorrow's lesson, just because simplifying takes quite a while to go over, and we had all the kind of recap at the start as well. But it is really important that you get the hang of simplifying today, because tomorrow's lesson does depend on that as well. So if you do have any questions, please email today, or tomorrow's one you'll struggle more with. So make sure that you are dropping me an email if there's anything you're not sure of. I'll also link the Corbett Maths one as well, because that's really good for surds too.